And then, where were you at?
I'm sick.
Where were you going? So she still had to go home and get to bed. She got to bed even later than you got.
This was yesterday.
That's what I'm saying. You were at her house till 11, right?
Yeah.
So then she's at home, so she can just go to bed usually. So she can go to bed at 11. So you still have to go home. And then you probably didn't get to bed until like 12. You cannot use that.
No, but we fell asleep at my house too. We still could live in that. You're jacking.
Little nap.
Yeah, you had jacking.
Let's see. Oh, we're recording now. All right. So why am I questioning whether or not 12 is the right answer? Why am I questioning whether or not? Because clearly everybody knows that the answer should be 12, right? You all know that. But why am I questioning it? Not really. 17, that's a confusing number. 12, not confusing. Why am I questioning if that is the answer?
Is X supposed to be the
X, I will tell you, X is this section, so that's not it. X stands for that. Don't know for sure. Or do we? You or not? I didn't tell you AB is the diameter, did I? I didn't say AB is the diameter. So the question is, would X still be 12? Can I say AB is the diameter? Say AB equals 24. So here's the point of this whole. You have got to be told in some way that you have the diameter in order to then solve for the radius. Like do the divide by 2 thing. This qualifies. We're saying that AB is a line segment. So if AB is one line segment, it has to be a dead straight line, a 180-degree basically line. And it does go through the middle. So we would say, yeah, that's enough information to say it's the diameter. In one of the problems, I think this came up. That's why we're doing it for better work. Where they didn't specifically say you have the diameter, but they give you the length of the line. It's basically just like it. They give you the length of the line segment. So since they're telling you that line is a line segment, it's all one line, we can assume that it's also the diameter. Otherwise, if they don't tell you it's the diameter, you can't just assume it's the diameter. I think that was all that I wanted to do. So yes, if that is the diameter, then yes, the radius is 12 and X is 12. All right, so now look at your book pages. We're on page 199. You weren't here last class. You didn't miss a ton of stuff. It was pretty easy stuff. Today starts off pretty easy, but it is not easy by the end. Not even close to easy by the end. Although I think probably it'll be a better, easier to understand. You tore out the pages, so 199. If you were not here last class, raise your hand. Then you need to tear out pages. You weren't here when we tore out pages? Oh. We're on. If you weren't here last class, you need the pages. You weren't here. So right there. If I've never told you, new students, phones up. It's Audrey. Why don't you move back? It's more comfortable to be on your phone.
Yeah.
Fuzzies when you're near your phone. 189 through 326. All right, so we're going to go through some easy stuff about a circle and then some stuff not so easy. I think this is where we ended. Well, it's not where we ended, but it's where we're starting. So look at page 199. So we talked about what a chord was of a circle, 2 points on the circle connected by a line segment. We will get into more complex stuff with that later. First, we're going to learn what an arc is. Well, you should already know what an angle is, but we're going to learn more about angles as it relates to circles and then what an arc is. I'm going to jump around a little bit. Most of this is in your book. You, in my opinion, some of the book stuff is complex, but it's saying the same thing. So you may want to take some notes in the areas around it. I think that'd be a lot simpler to understand than trying to go back and use what the book is talking about later. First of all, how many degrees in a circle? So if we start and we have a little angle that's inside a circle and we keep opening it up, and we open it up to where this A comes all the way back around onto the C, that's 360 degrees. So there are 360 degrees in a circle. If we measured the angle right here, we could come up with however many degrees that is. If we use a protractor, that is called a central angle. We're going to definitely need to know the difference between some different kind of angles. Central angle is one type. That means you are using the center point of the circle as your vertex. That's what makes it a central angle. Center of the circle is your vertex. So here's the next thing you need to know. The section of the circle that corresponds with that angle, so again, it has the same endpoints, C and A, is called an arc. And the symbol for arc is this little curved thing like that. So a line, when we did a line segment, we just put a straight line over the letter. When we do an arc, we're going to put a little curved line over the letters. So let me see you guys buried in your phones, please. So here's my first question to you. So if I'm talking about arc, true or false, we can have an angle greater than 180 degrees. It's true, yeah. If we keep opening, now we don't see them normally because like a triangle, all the angles inside the triangle can't be bigger than 180. So you can't certainly work in a triangle. Typically, we don't see it in rectangles, trapezoids, but in a circle, we will see them. If we kept opening this angle up, we can go past 180 and come all the way around. We just said we could have a 360 degree angle. So in a circle, we're going to deal with angles that are bigger than 180 sometimes. Keep that in mind. So now with that in mind, if I know the measure of the angle, the measure of the arc is the same measure. So this angle here was, what's that look like? Maybe 100 degrees. And we measure arcs, or one way we measure arcs is also in degrees. So if the central angle is 100 degrees, then the outside arc is also 100 degrees. They match up. They cover the same percentage of that circle, basically. This angle here covers the same percentage as that arc covers of the circle. But here's my question. Now I got to go backwards a little. I forgot to explain that one first. If I were to say arc AC, what's the measure of that arc? Measure it. So you might say it's 100 degrees, right? Because I'm going from C to A. Well, wait a minute. We just said we could have an arc bigger than 180. How do I know I'm not talking about that arc? Oh yeah, right? Just got So what's the measure of that angle then? If I say RKC. What would the blue measure be, by the way? The blue angle or the blue arc?
Oh, have to minus 360 by 100.
Ooh, something. So how do I know which one is RKC? That presents a problem. So we come up with a different naming convention, which probably doesn't make sense to you, but just a different way to name arcs that are parts of circles. If you have an arc that is less, so how many degrees in half of a circle? Like if we had a diameter drawn through it, it'd be 180, right? A diameter would split it into two equal halves. Each of those arcs would be 180, or the angles would be 180. If you have an arc or well, actually it's just an arc because we don't name the angles this way. If you have an arc that is less than 180, so this arc here is less than 180. It's less than half the circle. You just use two letters. So that's the way you name it. So if I named it like this, and actually I wouldn't even need word arc if I put the symbol there, that would be 100 degrees. If we wanted to name the other arc going the other way, you have to have another point somewhere on the blue part of the circle. So we'd have to put a point in there. It doesn't even matter what you call it. Call it S. And we would name that arc by saying A, S, C. So it tells us that we're not going this way to C, we're going to S first, then to C. So that's really what this picture down here is showing again. So we'll go over it again. Quick concept, again, nothing really like surprising, but if I know an entire circle is 360 degrees, all of these angles and the central angles inside the circle have to add up to 360 degrees. All we're doing is taking 360 and breaking it into smaller angles. So they must still add up to 360. That's all this one is saying. If you had 5 angles in there, then all 5 of them would add up to 360. So all the central angles have to add up to 360. So if an angle is less than 180, you would call it a minor arc. If it's greater than 180, it's a major arc. Again, the way we name a major arc greater than 180 is with 3 letters. The way we measure a minor arc less than 180 is with 2 letters. A semicircle is just half a circle, so it's a 180-degree arc. And congruent arcs would just have the same number of degrees, same measure. This is kind of a dumb theorem, in my opinion, at the bottom of the page. Get rid of some of all this stuff. I just told you that what's true about an angle and its arc. What's true about an angle and its arc. So yeah, they're the same measure, right? And you can measure them both in degrees. Arcs can actually be measured in other ways, so we'll get to that. But this arc here would have the same measure as angle 1. So if, what would you say that is? What do you think measure of angle 1 is? Take a guess. I don't know. I'm just trying to see if you guys can make an estimate on it. It's less than 90 is the first thing I always look for, is how close to 90 is it. So if it's less than 90, which it is, I would say 80 is not bad, maybe a little higher than 80 because it is really close to 90, it looks like. So maybe a little higher than 80. So let's say it's 85. So if that's 85 and that's 85, right, small, 85 and 85. All this theorem is saying is if two angles are congruent, So if this angle 2 is congruent and it's also 85, well, then their arcs are also congruent. Kind of dumb theorem, in my opinion. It goes back to sort of that whole reflexive and transitive property, and then there was a symmetric property or something like that. So we're not going to do proofs, so you're not going to have to name the theorems or anything. So just understand the angle has the same measure as its arc. So if the two angles are congruent, then the two arcs have to be congruent. And again, like I said, this stuff is easy. It will get difficult real fast in a second. Well, few minutes. More terminology. Again, nothing super surprising. If we have two arcs that are next to each other, so they share a common endpoint. J is the endpoint for both. So J is the bottom endpoint for this arc. It's the top endpoint for that green arc. Those are called adjacent arcs. Just like when we did angles that shared a side, they were adjacent angles. Sides that share an angle are adjacent sides. Same concept. The other concept actually is this. Yeah, this concept's in here. If I have a larger arc that I split into smaller arcs, that just means that the two smaller arcs have to add up to the length of the bigger arc. Just like when we did line segments, there was like, what was the name of the property? Additive segment addition property. I called it little plus little equals big. Same thing here. If I have a big segment and I split it into two little segments, then the little plus the little has to equal the big. Same exact concept, just with arcs now instead of line segments. Let's see. So again, this is just saying the same exact thing I just said here. XY plus YZ would have to equal XZ, arc XZ. Go ahead now and do all of the examples and check problems on both pages. This one you may not be able to do. Example 3, you should be able to do the other ones. So page 200, 201, try to do all the examples and checks. Some of them are very easy. Example 3 is a little, I mean, they do it for you, so you can follow. Lot of phone tapping going on in this class. Lots of phone tapping. Hey, trigger pages. Trying to, is that what you're implying? Where you get trigger pages. Yes, sir. Friends like that, who needs enemies? Looked at you like wasn't gonna throw you under the bus. Although she kind of did by the way. I tell you, I graded one class's quizzes and how horrible they were. Oh, I haven't graded this class yet, but the class I graded is normally my highest averages, and it was bad. 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 I don't know. Like the fact that you have your whole hand wrapped around instead of just like a couple things. It was weird that I found that weird. I like that bubble.
Do you need it?
I don't know. Let's see. Legal.
This is what we're doing.
Oh, we haven't gotten that yet. We will. I mean, I'm probably never gonna use it class, but I like that problem. You can't solve it now. We'll get to how to solve that. I'll give you, oh, actually, I'll do attendance while you're doing that. Like I said, 1 and 2 should not really be an issue. The examples are the checks. 3 is a little trickier. Although with the example that they pretty much did for you, you should be able to figure out that. Oh, there we go. I feel tired. I go hit golf balls today. Maybe. What? There we go. Let's see who's here. He's definitely here. He's probably not here. He's not here. He is here. Interesting. CBC. Lady Late. Victor. Oh, yeah. Audrey is building up some tardies. Were you on time to any classes today, Audrey? Were you on time to any classes today?
No, I got here late. And then...
You do know the tardy policy here, right? So once you hit 10 tardies, or maybe it's 11, they might give you one grace tardy. After that, you start getting detention. Yeah, I see that because you started on classes today. Yeah, and that's the only thing this school takes seriously really is tardies. You can skip and they don't get in trouble, but don't be late. That I cannot see. I just see what happened today. I mean, I could look it up if you really want to know, but you can also go and ask the office, like, the front office can get you a count of all your tardies. Or I can look it up if you can't get it from there. I'm sure they can give it to you. Yeah, it'd be good to know because, like I said, that's the one thing they do actually enforce is tardies. I bet you weren't late to your private school classes, were you? And again, we don't really say anything about it. We just mark you tardy in the system. So you wouldn't really know that unless somebody told you the policy. I think they pull a report eventually, and then at some point when you're over the limit, they put they call them passes. It's not passes, it's a detention slip. But they put that in the mailbox of your first class teacher. and then they give it to you in that, but telling you you had it on attention. And normally it's, the next day, so you can. Actually, maybe it's not anymore since they do it during lunch, not after school. So they might give it to you the same day. I don't know. It was under a bridge. She was under a bridge. All right. I think I'm done with that. All right, let's start going through these. Again, nothing super, super challenging yet. Although example 3 is kind of setting us up for the stuff that gets a little tougher. Oh, wait, hold on. Oh, man, I just totally recorded attendance. Example 1. Here we go. Pretty blank paper you got there. All right, so in this example problem, again, the only concept is that all degrees add up to 360. All the central angles, I should say, add up to 360. So if we know 40 and 85, what is angle BAE? 90, right? So we know a 90, so write in all the information you know. Well, we know 3 of those 4 angles, which means there's only one that we don't know, so we can solve for that. So they took the angles we know, they're adding them up. So what number did that give you? 215? I think should have been what you wrote there. Yeah, 215. So then to solve for x, you'd subtract 215 from the 360. You should have gotten 145. So angle x would be 145 degrees. Oh, normally the images will be pretty, like, what's the word? Like they're drawn to scale. So whatever it looks like the angle should be is probably what the angle is. So for example, that looks pretty close to a 90-degree angle. Well, it was 85 degrees. That looks like it's getting close to a 180 degrees. Well, it was 145. So that'll help you maybe know if you did some math wrong. So next problem, same concept. It's actually easier, less angles. Add up the 2 angles you know. Subtract it from 180. What do you get? What do you get? Exactly. It's the same problem. Didn't even try it. Yes, even easier. It's easier. Right. It's only one missing number. You only have one missing number. No. That's horrendous. But that was left over when I did when I scroll, it doesn't move. It doesn't even close. You need to get on the ball, girl. Yeah, this one they did for you. These are the ones you need to do when they're not giving you as much information. Do the check. I'm sorry, not that one number. Oh, what'd you get? 50. I just asked what you got. 50. The one down below is easy too. What are you talking about? They did the whole thing.
I was watching this about trees.
But that's not what they're asking you for. So what else did they tell you in that? What else do you know about that problem? What's it tell you in that problem that you can use to solve for QM? Something really important they tell you. No, we're solving for
The
MQ.
180.
Well, what about 180? What do you mean by 180? What? So, but what are they telling you that's allowing you to, this is the first part of the lesson. What are they telling you that's allowing you to know that something's 180? I think you're thinking the right thing, because if that is how you solve it, oh, you're just reading the problem. Where's that 180 coming from? Troy. So what are they telling you in the problem? Like, literally, they tell you this is the very first thing. Yeah, they're telling you this. This is what tells you that. They're telling you PM is the diameter. So sometimes you have to you have to draw a conclusion that they didn't just give you in the problem. They told you that PM is the diameter. They did not tell you anything about 180 degrees. This comes from the fact that PM is the diameter. If I know.
She doesn't know what a diameter.
Well, that was the first day, so that's a little sad. So, like, you weren't here when we
No.
last class?
No.
We did this all last class.
Remember you FaceTimed me last class?
Not last class.
Yeah.
Oh, because you came and saw me. I saw you one day after that. Was that yesterday?
Yeah.
Maybe that's what I was thinking. But you should still know what a diameter is. You learned that like forever
No, I don't know. There's one all.
So you need to know diameter is this line from one side of the circle through. I mean, I did do this for bell work, so still should have known it. So one side of the circle through the middle to the other side. That's a diameter.
What's the middle?
The radius, which is what you're talking about now, I believe, is half of that. So it's from the middle to one side. So all of these are a radius. That's a radius, that's a radius, that's a radius, even that's a radius. That's why the diameter is twice the radius, because it's just it's a radius here and another radius there. All right, so now if we know that PM is the diameter, that automatically means this is 180 and this is 180. The diameter splits the circle into two semicircles in the correct order. So if we know that from P to M is 180, we know that's 115. So what is QM? That's how you solve for QM. You just say, okay, well, I know the big arc is 180, or the big angle, whichever way you want to think about it. And then I know this arc is 115, so I need to subtract that 115 from 180. And is that 65? Is that? Yeah. So you should have gotten 65 degrees. Whether you're thinking of that as the arc or the angle, doesn't matter. Well, I guess it does because they ask you. Yeah, they ask you for the arc, so we should be doing it. 65 degrees. And again, this big arc here would have been 115. Bless you. So that arc should have been 115. We just knew that from the measure of the central angle, though. All right, so now you should have been able to do all of these as well. So we need M. I'm going to come back down to the picture. You have them in your page. M in P and M in Q. We want to know. Never mind. I'm just going to erase it. So we want to know M in P and M in Q. Let's see. So we need to go from M. Oh, well, what is M in P? We just said what that was. Yeah, so what's the degrees? So that's 180. So we can just write that in. That's sort of just given to us. You do have to understand that it's 180, but really it was just given. And then what was the other one? M in P, M in Q. Is that what I said? Yeah. So if we know that's 180 right there, all we're doing is adding in the 115. So you just add those two together. So it should have been 295. All right. Is that what they were asking for? Yeah, MNQ 295. All right, so if you didn't do it, do the check. Now know how to do that check problem. Right, Hannah? Sometimes.
Beast.
She, then she assaulted me.
Oh, you did not mean it.
After a bad day.
Didn't bounce away again.
You need to block it out.
No, Elijah needs to talk. No, make them go outside and have a little therapy session.
Come on.
I wish I could bring
It's all
in.
because he stole her pencil.
They have the. I think it's just a joke, but I've seen it on TV shows where they do it. They have these boxing gloves, like gigantic, like they're so gigantic, and you can't really swing them very fast. You just actually go at it with them, and they can't really hurt each other. I would let you two. I would let you two guys do that. If I had. I don't.
Think of one.
You get bought.
Think of one. Jump on it.
No, gotta use the gloves.
The kitchen.
Yes, but stuff.
I've seen other versions of that.
Oh,
Too.
it's also stay. I just remember there was in the bubbles. It was bubble. What does this mean? Mr. Gill, that's art. So G J. That isn't even not. G L J. GJ is diameter.
Go from G to L to J.
It's semicircle.
Yeah.
How am I supposed to find that? Oh,
What is it?
360. There we go. It's 180.
There.
But that's semicircle.
Yeah, 180 is a semicircle. Whoa! Yeah, knock it off. That's
Yeah, stop breaking this stuff.
exact.
Balance.
Respect other people's property. So GH is a pretty easy one. That's just given by the angle. That's the central angle. So if that's 120, then that arc is 120. I'm sorry, 122. Then that arc is 122. GLH would be going the opposite direction. Oh, I don't like that. GLH is the other arc on the opposite. So what's true about those two arcs? Form a circle, what do they have to add up to be? So what do we need to do to figure out GLH?
Yes.
So that would give you GLH. 238 sounds right. GLH 238. And then GLJ is just almost a definition thing. If we know that is the diameter, then we know that is a semicircle. GLJ is 180. That's more of a definition vocabulary.
I can hear you. It's collapsing.
Oh,
Oh,
look how perfect a circle that makes. I love that.
that's a case thing.
I know, but it's still perfect. Girl, you. All right, now it gets a little more difficult. So all that other stuff is easy.
I can
So
do
if you are super excited that you're getting it, none of that's going to be on a quiz. That's stuff I expect you to know. Now the stuff you have to learn, which some of this isn't even that bad, but it will get a little tougher in a minute. So here's what we have to start doing. we're going to convert some different things like about a circle into different types of measurements. It all revolves around this concept I'm about to give you right here. We're just trying to figure out what percentage of a circle are we talking about. So in all the next problems, we're just really focused on, well, what percentage of the circle are we taking up? So for example, this orange section, I guess I can still use red. That's fine. That orange section, or the orange arc, we'll call it, from E to D, or D to E, whichever way you want to go. How much of the circle is that taking up? The orange section, the arc from D to E, so the one it's talking about. Yeah, it tells you right there. They're telling you right there how much it takes up. That's what a pie chart is. A pie chart is out of 100% of something, how many, what percentage is each different sector. Like a lot of times when they do surveys, they'll give you a pie chart and say, you know, out of, well, this is what this is. Out of all these teenagers, what do they spend their time doing? Well, 12% use search engines, 7% do games, 14% music, blah, blah. So it's a percentage out of 100, but they use a pie chart to create a circle, basically. So what we're going to do is we're going to say, okay, well, this takes up 12% of the circle. Let's convert that and see how long this arc is. What is the length of that arc in degrees? So again, the measurement we're going to do, or the math we're going to do, I know this arc takes up 12% of the circle. So that arc is 12% of the circle. How many degrees are in one full circle? 360, right? So I want to know 12% of, and if you don't remember this little trick, the word of means multiply, especially when you're dealing with percentages. So 12% of 360 just means 12% times 360. Well, no, you should be, then that's exactly what you should be doing right now.
Yeah, I can.
Yeah. Yeah, the percentage button it's a second function above the left parentheses button. You haven't seen it yet. So you just say in your calculator 12, second function, hit the left parentheses, which will give you percent. So 12% times 360. Oh my.
I got it.
No good.
No, we're not 3.2. I literally.
So, oh, and it would be in degrees. So that orange section is 12% of the circle, and it is 43.2 degrees. That's how long that arc is. It is asking you. I'm not filling out all, like, I see now that they did want you to know that it was a minor arc first. I don't always fill out all the blanks, but yeah. So what Audrey just said, technically that should be down here. And they are asking you, I believe, is it a major or minor arc? So if you're really trying to fill out all the blanks. Let's see, what else do they want to know? So angle, oh, that's the same, that's how they solve for it, I guess. Wait, what are they doing? Yeah, I don't know what they're doing. Oh, I'm sorry. So that's actually not what they wanted there either. I mean, they eventually, that's the final answer way down there. They just were getting you to name the angle here. That's what they wanted there, the name of the angle. So again, I don't always follow. The ultimate goal was to be able to get to the end result if you didn't fill out all the.
That's what's DPE? World B. That's not even B. There's no B. Yes, there is in the middle. Oh. Yeah, how good of a friend I am. You think it's a bad friend.
All right, now try to do the other one on your own, the one right below it.
Dude. What? Can I use the bathroom? I put my deck back. Look how I use the bathroom.
They related?
It's a
related?
line girl. No, it's up to you. Waste my. I'm gonna bring it to you tomorrow in the same class. Oh, if it's not still in your room, separated, you throwing it. I know about coke in Redmond. If it stow it. Might be.
What are you looking for?
My hair band.
Why do you throw that? Do you like my song? Turtle's a party hat. That does not look like a turtle.
Just appreciate it. Cute. The fact that it's a turtle is cute, but it's not very.
You have party hats on.
And that's what I'm saying. That is the fact that it's a turtle with a party hat.
That really look like
But it's a horrible turtle.
That's a Dollar Tree.
Which would explain why it's not very cute.
Wait.
Cute idea, poor execution. All right, so you should be pretty close to done. It's same exact problem.
Yes.
Pretty easy once you did one exactly like it. Oh, what's the most popular sport?
Wait, what's the same thing?
No. No. Oh, where's? Yeah, they didn't even have soccer, did you? Oh, yeah, it is. Soccer was almost in them.
I got it. Is it 6?
Apparently, America would disagree with you.
You.
That's wrong.
I'm not giving you.
I'm surprised baseball. Baseball probably used to be bigger than that. Baseball is behind basketball.
I'm not giving you. Like finding shoes on that with Jessica Simpson.
Were you the one asking me about this?
No, I showed you my shoes.
Yeah.
Jessica Simpson.
Okay, so you were the one. You asked me if I knew who that was.
Yeah.
All right, so what do? Let's call on Kai. What do we do?
Nothing. You're picking. I agree with that.
So if we know this covers, it is CD right now. We know this covers 17% of the circle. We know a full circle is 360. We want 17% of means times 360. And that came out to be 61. 61.2? 3?
Bro, what is that face?
3? I think it's 2. Did you round? You don't round up. It's 0.2222 or something, right? Or,
Yeah, give it a 17.
So, but yeah, again, as long as you're doing this math right here, that's all. All right. So now I think is where it starts to get real. Oh, wait. I can't. What did you say? Say that again. Say that again. Say it again. Because we're about to get into something that you've never seen before in your life. Like all of this stuff is actually not brand new. Oh, actually, we're not there yet. It's next. You can do that. Go ahead and do that. That's pretty easy.
Oh,
Do both of them. Example and check. You don't need me for that. That's super easy.
Go to the vending machine.
What is more easy one?
Why can't you? I don't want to get up. I don't want to get up either. Mr. Joe, just because you can I go to the vending machine?
Yeah.
No, I'm thirsty.
You're good.
Me too, but sometimes I'm gonna have to suffer.
You're about to get into the most difficult thing we've done in
Okay,
geometry.
but I can.
Actually, cosine and sine was a little difficult. This is right up there with that. The more difficult, like the last one.
So if I do this, can I?
No, because this is not the new stuff. This is the old stuff. Go. Because you do have to be here for the new stuff. Go. You better be fast. Like, don't sit out there forever trying to figure it out. Or if the vending machine's not working, don't try to get somebody to fix it. You need to be back there. Because you will be totally lost on what we do next. So. You can see it and you'll still be totally lost. It is not easy.
Spell iron.
Hmm?
Spell iron.
No.
Now I smell this thing. This thing gives off some kind of like an electrical.
It's not level 10.
Oh, I should have let her go. Audrey now.
Yeah.
Got enough time. Yep, that was a brain cloud. Yeah, totally got Audrey. Let's see. I don't even remember what they asked us in this. I'm just looking at it. I haven't even. Although I don't believe this was that difficult. Well, listen. Defined measure of W. Oh yeah, that's easy. Come on, man. The measure of a. Yeah, that's easy too. Actually, the same exact problem, but off by 1 degree is all. All right, so this is just, they're doing that concept of little plus little is big. So if we want to know the arc from here to there, I'm going to kind of do these both at the same time. There to there. All we're doing is we're taking the two little arcs, little plus little equals big, and we're adding them up to equal the big. So 62 plus 90 is 152. And there they only changed it by 1 degree, which I think is funny. 63 plus 90. So again, I could make that a lot more complex for sure. So make sure you understand the concept, but there are definitely ways algebraically I could make that math much more difficult by putting a variable somewhere in there and making you solve for the variable.
You literally
Always got something to say.
you don't even have the pages out. You have your phone.
No phones. All right, here's where it gets real. Some of this you're just going to have to memorize. I'm not going to go into any proofs behind it. Although I guess if you don't use their formula, and if you understand the way I do it, you don't really have to memorize anything. The way they do it, they just give you formulas. So they just tell you to convert from like degrees to radians, do this. To convert from radians to degrees, do this. What I don't even know what that's saying. True. Ratio of the length of an arc to the circumference of the circle is equal to, like, all that is just gibberish to me. So I'm going to explain what they're saying. So we got this circle. And we're going to convert it to the number of degrees that that part of the circle takes up. So let's do some easy examples. Let's try to draw a pretty good circle. Okay. So we take that circle. What is the formula for the circumference of a circle? We did it last class. There were a few of them actually, but there's one that we're going to use.
Oh, 2
Maybe.
pi.
Yeah.
That's the one we're going to use. We said it is 2 times pi times r. That's the length of that line. If we were to cut that line right there, stretch it out, that would be the length of that line. That's what circumference is. Distance all the way around, length of the line, perimeter we said is kind of the same thing. How many degrees in a circle? 360, right? So we know that the entire degrees is 360. So what we're going to be doing, we're going to do several things. We're going to start off by saying, well, if we know the measure in degrees of an angle, If we know the measure of degrees in an angle. That's what I was waiting for. She didn't stop. So let's start by taking one that's pretty easy. So the center point is right there, right? What's the measure of that angle? 90 degrees, right? We have a 90-degree angle. How much of the circle is that taking up? It's a fourth of it, right? 25%, 1/4 of it, however you think, 0.25 if you want to do it in decimals. So if we wanted to convert the circumference, so this is a whole circle, right? A whole circle is 2 pi r. That'd be the entire circumference. If we wanted to say, well, what about if we just wanted 1/4 of this? We don't want to know the whole circumference. I just want to know how long this is. What will we do? Right? Oh, I guess we need to show this real quick. How do we know it's 1/4? Where'd you get the 1/4 from? Other than you just kind of know it's 90 degrees, you know there's maybe 4. But mathematically, what would you do to get 1/4?
360.
No, not that.
Since it's like
Nope, because we don't have 4. You're using what you already know the answer is. That 4 is actually the answer we would get. What are you actually dividing by to get 4? You divide by the degrees, not by 4. Not 360 divided by 4. We take the number of degrees, right, 90, and we say 90, and you're actually not dividing 360 by 90. You're dividing 90 by 360. So if you take 90 divided by 360, if you simplify it, it's 1/4. You keep it as a fraction. If you change it to a decimal, it's the 0.25 we mentioned. Or if you make it a percentage, it's 25% of the circle. So here's your first step that you need to understand. We need to figure out what percentage of the circle is that degree, is that angle. Or the arc, if we're talking about an arc. But remember, arc matches the angle, so it's kind of different. It was easy in the 90-degree angle, because we just know that's 1/4 of the circle. Most people do that, I think. I'm not worried about it. I don't know. So, again, this is like the most difficult thing that we've done. I don't have time to like get off topic.
You're right.
Because people are going to be totally lost on this, even if you pay attention.
Doesn't even have a
Totally lost. So, again, you too much. So, I take the 90 divided by 360. It tells me it's 25% of the, I like using percentages. If you like decimals or using fractions, that's fine. To me, 25% just works better for my mind. So I'll use percentages a lot. So if I know that's 25% of the circle, I need to take 25% of this number here in order to see, well, what length would that be? Again, I don't have a radius, so I can't really plug in the radius yet. But I would say, okay, well, let's divide that by 4. So I'm going to take that divided by 4, and I get this weird measure. So this is where's the word? This comes in. There's this thing called a radian. That's where we're going with this. A radian is just taking the circumference and converting it to just part of the circumference. That's kind of what a radian is. So in one full circle, again, regardless of what the radius of the circle is, doesn't matter what the radius is. Radius could be like teeny, teeny, tiny. So it could be a teeny, tiny circle. It could be a gigantic circle. Doesn't matter. Because we're just talking about in relation to Well, I guess the percentage. You could think of it as the percentage of the circle. One full circle has 2 pi radians if you go all the way around. So again, that's my point. This gets confusing because you've never heard of this radians thing. It's just another measure of distance, and it's only for a circle, and it's based on this formula for circumference. It's just a measure of length, but it's a measure we can use for any circle. Like, we're not worried about it. It'd be the same. It's kind of like how far around the circle have you traveled? If you go all the way around, you travel 2 pi radians. You go halfway around, you travel just 1 pi radian, because halfway around would be half of that. So try to think of radians as just a measure of how far around the circle did you go. If you start here and you go around the circle, if you make it all the way back to where you started, that would be 2 pi radians. And again, it comes from the formula for circumference. 2 pi is in that formula. This stands for radians. I'm sorry, for radius, not radians, but it's based on that measurement. Oh yeah, absolutely. Yeah, you're going to get a lot of fractions and decimal numbers. Yeah, it's not always going to come out. Very rarely will it ever not be a decimal. But you will see the pi still in there. That's the tricky part. Now, you could convert pi to a decimal yourself, and we said that on a multiple choice test, you'd have to convert every answer they have to a decimal. So that will work. But I'm still trying to get you to understand what this thing is, and it's not easy to understand that, I don't think. I mean, if you can read what they did and that makes more sense to you, then great. It's a very different concept from anything we've done before, anything you've ever done in math, even when you had some geometry and other maths. So I think the best explanation is it's kind of a measure of how far around the circle did you make it. And it's based on the formula for their circumference. Now, what happens is, depending on how much information they give you, you might also be able to measure the actual distance that you made it around. So this is just kind of like saying I made it 25% of the way around. Like if I had a 90-degree angle, I made it 25% of the way around. Well, we would call 25%, I don't know how you say it. I would say it's pi over 2 radians. We don't use this when we're talking about radians. That's not involved in the word. So pi over 2 radians means I made it that far. That's pi over 2 radians. So actually we can write that in. That distance is pi over 2. Now if I go another quarter of the circle, so now I made it to the other side, that's another, so this arc here would also be pi over 2 because it's 1/4 of the circle. The whole semicircle would be pi radians because again, it's half of this. We made it halfway around, then it's half of that radians. Then if I do another 90-degree angle, that would be another pi over 2. So if you added them all together, it would be what? 3 pi over 2 radians. And then finally, if I came all the way around, that would be another pi over 2. Well, that would be back to 2 pi radians because 4 over 2, 4 divided by 2 is 2. Again, I know most of you are not getting this. And there's some steps that you'll be able to do to just get some answers. Yeah, I mean, but there's not an easy way. I mean, again, reading what they do, you can try to read what they do, but that to me is worse even than trying to just understand that it's just a measure of distance around. Eventually, what we're going to do is this. Yep. Well, you can use all kinds of measures. That's the thing. We can use radians. We can use degrees. Again, this is just 90 degrees. That's easy for you to understand. You're like, yeah, I know that's a 90-degree angle, so that means the arc is 90 degrees. It's the same concept. You just got to understand, instead of one circle being 360 degrees, it's 2 pi radians. Just the measure in radians because of this formula. Because the circumference has 2 pi in it, that's where that 2 pi comes from. One full circle, one full trip around a circle, one full length of a circle, whatever you want to call it, is just measured in 2 pi radians. It has to do with the fact that you have a radius of a circle, and the formula for circumference is 2 pi times the radius. If you just remember this, that it's 2 pi radians or 360 degrees, you're ultimately doing the same exact calculations as you would do if it was degrees. If we wanted to know how many degrees 1/4 of the circle is, we would say 1/4 times 360. You're doing the same thing. It's just you guys are used to degrees. Degrees are not new to you, so you're fine with that measure. You've never heard of this radians thing. So as long as you remember, one full circle is 2 pi radians, it's the same math. You're taking some number, some percentage, and multiplying it times 2 pi instead of 360. If I can come up with a better way to explain that concept of what a radian is, I don't think I'll be able to, but if I can, I will. Just understand though, one full circle around is either 2 pi radians, or you could say 360 degrees, regardless of how big the circle is. It works for any size circle. They're always going to be 360 degrees, always going to be 2 pi radians. We will then convert the actual length of the line, the length of the arc, though, using what is the radius, like how long is the radius. That does change the length of the arc. We haven't even gotten to a problem yet. I'm just trying to go over those concepts. Now we're going to try a problem. All right, so now look at example 5. So here's where we bring the radius back into the problem, because they do want us to solve. We get rid of some of that writing. So they do want us to solve for AB. So they want an actual number that represents the length of that arc. So here's how, in this will make more sense than what we just did, I think. If I want to, and again, they don't tell, so this is the one where I told you the whole bellwork problem came in. They don't really tell us that we have the diameter in this problem. Right? They don't say anywhere in here, this is the diameter. Because though they're giving us this line and writing the 14 like that, we just assume that's the diameter. So if that's the diameter, what's the radius? Radius is 7, right? So we know the radius is 7. So what would the circumference of that circle? So do it. Well, not pi times 7. So do the circumference. Okay.
Oh, just for that?
No, I want you did the whole problem. All right, I want the full circumference first. We'll work on that.
Oh.
So somebody do the full circumference for me. Yeah, I would have still thought it would have been bigger than that. We'll find out in a minute. What is again, sometimes they're going to leave pi in the answer. Sometimes they'll multiply it out, using the number for pi. So what's the circumference for if we wanted the full circumference? It would have to be bigger than that because the radius is 7. So 7 times that is 14. Oh, 14 times. Well, so multiply it out. I want the whole number.
What do you mean?
Like multiply all that out.
That's what I did.
What in the world are you talking about?
Look.
2 times, so pi itself is 3.14 something times 7.
Look.
Oh, I thought you said 14.
No, I said.
Okay, so 40. So say it again then. So we get about 43.9. So the entire circumference, again, yeah, the entire circumference is 43.9. So we're not really using radians as this, so it's not that bad to do. We now then need to say, okay, well, if that's the entire circumference, how much of the circle is this? That's where this piece comes in. We know a full circle is 360 degrees. We know that arc is 80 degrees, arc or angle, whichever way you want to look at it. So we're just figuring out what percentage of the circle is that arc. So if you do the math on that, come up with a number for that. 2/9. Yeah, so 22. I'm going to write it as a percentage. It's 22.2%. Or you came up with, if you divided out 0.2222222 repeating forever. Is that what you got? So if this arc is 22% of the whole circle, or 2/9 of the circle, so you could also change that into a fraction. So that fraction is 2/9. Then I just say, okay, well, 2/9 of the circumference would be what? So multiply 43.9 times 0.2222222 forever. And it's about a fourth of it, so should be a little over 10 probably, maybe. Yeah. Oh wait, no, maybe not a little over because it's not 25%. So either somewhere around 10, just over or just under 10. Come back to that. What was it? That sounds about right. Yeah, I'll come back to questions. First of all, though, how many people got that? Like you on your own were able to do that. All right. Well, I mean, I didn't expect many people to be able to get it. So now let's go back through it again. And this is where you guys have to kind of help me out because I don't know where I lost you. So again, all we're doing is we want to find the length of AB. We start by saying, okay, well, I know there's a formula to figure out the length of the whole entire circle, the circumference. Got that? So we figured that out. That's what this number is. That's color code. So this here, 43.9, is the entire circle. So that red line is 43.9. We only want to know the blue line though. So what I did is I said, okay, well, what percentage of the circle is just that blue line? I know it's 80 degrees, right? That just tells me that. How much is the whole circle? How many degrees? No degrees. 360, right? So what percentage of 360 is 80? So I took 80 divided by 360 to figure that out. Just think about it. If it was 180 degrees, you would just say 180 divided by 360. If it was 90, you would say 90 divided by 360. That gives you the percentage of the circle. So 0.222222 is probably what you got. But that's if you convert that to a percentage, which is all I did, it's 22% of the circle. So again, it's 2/9 of the circle is really the number we're using. You just multiply by, yeah, you multiply by. I thought same thing. That's what moves the decimal. It's multiplying it by. If you don't want to convert it into a percentage, don't. I mean, the best way to do it is to say it's 2/9 of the circle. Problem is, if they're not numbers that simplify easily, you're going to get some weird fractions if you try to leave it as a fraction. So that's the only reason why I say convert it to a decimal most of the time. Regardless, that you're taking this number and you're multiplying it times the circumference. That's what you're doing. Times the whole circumference. So there will be some practice problems like example 5. So again, I know a lot of you are not getting this yet. Today's the first day we're doing it. All right, now this one's a little tricky as well. It's not the same thing we just did. So this one is where we're coming back into the radians thing. So again, I'm going to draw a picture. So if I start at that point and I go all the way around, how many degrees is that? 360, right? Should always know that. All the way around, I made it all the way around, 360 degrees. If I make it all the way around, how many radians is it? It's the one you got to remember. 2 pi, though. Remember, it's 2 pi, not just 2. So if I make it all the way back around, it's 2 pi radians. So here's what I have to do. I have to convert this 240 degrees into radians. And I'm just going to leave pi in there. That's what this means, as a multiple of pi. So I need to figure out what percentage of the circle did I travel if I made it 240 degrees. If I make it halfway around, how many degrees is that? 180. That's easy, right? 180. So how far around would I make it if I go 240? Like, would I make it all the way back to like a 90-degree angle there? Would it be that? Or would I be short of it or over it? Like, that's what I would compare this with. So again, 90 degrees would be 90 degrees there, 90 degrees there, plus another 90 degrees. How many would that be? 270, right? So 270 would be coming all the way to here. I'm going to be short of that. So probably somewhere in here, I would say I stop. That's about 240, because 90, again, 90 would be all the way up to there. I'm going to erase that 90 because I didn't make it 90. So somewhere around there. So here's the next piece. I want to figure out how far around the circle did I make it? Did I make it 100%? Did I make it 50% of the way? How far did I make it? What do I do to figure that out? Halfway would have been what? But what degrees, number of degrees? Wouldn't 180, right? So the math would have been 180 divided by 360. That's 1/2 of the way. So what do you think we need to do to figure out how far around 240 is? Don't add. We do the same thing we just did with 180. So divide what by what? So 240 divided by 360. You're always just going to divide by 360. I'm going to give you a formula in a second. I'm trying to get you to think about it first. So 240 divided by 360 gives me the percentage I made it, like how far around I made it as a percentage. I think it comes up to be like 66.6 repeating percent. Is that right? So I made it 66.6% of the way around. Now I just have to take that number and say, okay, well, if that's how many degrees I made it, it's 66.6% of the way around. Just multiply that by the times the 2 pi. Because again, 2 pi would be a full trip around the circle, but I only made it 66.6%. So you would take, I'm just going to do it in the form of a fraction. 2/3 is what this converts to. That simplifies to 2/3. So I would say 2 times 2 is 4 times pi. And then I'd have the 3 on the bottom. If you convert it to a decimal, that's fine. I'm not concerned about your final answer. I mean, final answer needs to be correct in some way, but they do say they want it as a multiple of pi, though, so I guess you theoretically should be leaving pi in there and writing it like this. You could write it as 1.33333333 times pi, that as long as pi is in there somewhere. So the important part from this radians lesson, you got to understand 2 pi radians is 1 trip around the circle. And you will sometimes go more than one trip. Sometimes you'll have more than 2 pi radians. And that's the equivalent measure of 360 degrees. That's what everything is based on. And then you just got to figure out what percentage of the circle are we trying to figure out or compare. I don't remember if we made it any farther than that. I feel like we did in class, but maybe not. I think that's where we ended in the end class. Oh, no, I'm sorry. We did this one. We did do this one. So again, it's the same concept. So I could use a circle again. So really quickly, we're just going backwards the other way. So I have a circle. Again, now 2 pi, because now I'm starting with radians. So 2 pi is what I'm starting with. And I want to convert that to degrees. So I'm going to convert that to 360 degrees, like to degrees. Did I make it all the way around if I went 11 over 6 pi? That all the way to 2 pi. Figure it out. Divide it out. There's 11 divided by 6, 2. Short of 2, right? It's less than 2. So I did not make it all the way around. I got pretty close. So I made it all the way around. Like probably somewhere all the way around up into here to 11/6 pi. Because again, 2 pi would be 12 over 6 pi. So I didn't quite make it to 12. I stopped at 11/6 pi. So I need to figure out what percentage of the circle is that. So you would just say, and this one you probably would want to convert everything to decimals. Say 11 divided by 6. You really don't need the pi because pi is in both of them. So what decimal is that? 1.83? Repeating probably. So that is a decimal. We need to figure out what percentage of the circle that is by dividing it by 2, because that would be a full circle. And if you put in like a whole bunch of 3s, this comes out to be, I think, dead even. If you round it off to just 1.83, you're going to get a rounding error. I think. So what percentage of the circle did you get? So 91 point. So is it repeating? So, or it would be 0.91666666 repeating if you just kept it as a decimal. So I now need to take that and take that percentage of 360 to get the degrees. I went 91.6% of the way around. Well, how many degrees is that? Well, I need 91.6% of 360 degrees, because 360 would have been all the way around. And I didn't quite make it all the way around. And you should get, if you don't get it exactly, you should be really, really close to that number. They gave you the answer on this. Yeah, so again, if you would have put in a whole bunch of 3s here and a whole bunch of 6s there, it probably would have come out right on 330. Or if you left it, now remember, you do have a fraction button. You can always just in your calculator, you could have made this a fraction and said 11/6 divided by 2, and then kept it as a fraction, and then used that fraction and said times 360. That would have probably come out nice and round on 330 as well. So you can try to do the check on your own. We're not going to go over it today, but you will be expected to know how to do all of that. So today would just be first day, so we have another day, another full block today actually to do it. I told you it got a little tough though. And we'll have to do example 8. So what page is that? 203, 204 examples and checks. Yep. Oh, did I not tell you? So your quiz, since we have a weird week next week, your quiz is on Wednesday. Wednesday is the skinny day next week. Monday, you go to your second period class in the morning. So they